Okay, so I am here to talk about microstates. I think I talked about microstates before, but back then, microstates was actually Ember specific. So it's kind of ironic that we're coming full circle now that like microstates has been extracted into a completely separate library. We're using it in React and Ember, but it's good to come here and talk about it now that it's like this is kind of the community and the framework that gave birth to it. So my name is Charles. I think I know almost everybody, but hello to the folks that I haven't met. I'm Cowboy D on Twitter, and I am an engineer at Frontside. What I'm here to talk about, we'll get like serious for a moment, is one of kind of the fundamental, transcendental, profound realities of the universe. This is something that is so real, so profound, that you might actually have to like hold on to your scalp so that it doesn't splatter onto the ceiling when I blow your mind. When I tell you numbers can increment. I know this seems crazy, right? But it's actually true. Numbers can increment. Numbers are really useful. They're amazing things. But incrementing, that is definitely one of the things that they do. So because numbers are things that we work with in our code, and numbers are things that can increment, sometimes we find ourselves incrementing numbers inside of our code. So this is actually something that you might have written yourself, where we've got some increment action, and we're taking a number, we're adding one to it, and we're putting it back into the place that it came from. That's something that's pretty common as Ember developers. But it's not just Ember developers that do this. This is how you might write Ember code to do this. But if you're writing React or you were using Ember Redux, you might have something like this, where you're also incrementing a number. And again, the reason that you would find yourself writing this Redux code is that incrementing numbers is something that numbers do. And it might come as a shock, it might not, but there are other frameworks for managing numbers, and there are other ways for incrementing those numbers. So if you're not using a controller, or maybe you're using Redux, or maybe you're using MobX, or who knows, maybe you're just using like a vanilla Ember object. You can just see like, we take a number, we add it to it. It's not really controversial. And these are all really, really great solutions. The only question that I have is like, why are we doing that? Why are we telling computers how to increment a number, right? Like, why are we actually taking that thing, getting it out of memory, adding it to numbers, and putting it back into memory? Like, why should we have to do that? We already know, right? We know that that's something that we can already do with numbers. If we have a number, we can increment it. We know if we have an array that we can push things onto the array, right? If we know that if I have a Boolean value, that toggling it is something that I can do. That operation is implicit to being a Boolean, right? Like we know that, but just for argument's sake, we're going to unpack that a little bit. We're going to think about what is a Boolean value, okay? Really, like if we just boil it down to its essence, right? So a Boolean value, there's our Boolean value. There are two states to it. There's a true state and a false state. We know that because we use Boolean values all the time in our UI code. We can draw those two states up there. They're really, really useful. And what's furthermore is we know that there is a strict set of transitions between those two states. So, for example, we can toggle a true value and it becomes false, right? We can toggle that false value and it becomes true. And there are a couple of other operations. We can take a true value and set it explicitly to false. We can take a false value and explicitly set it to false, and we go back to that state. And we can move from false back to true by explicitly setting it, or from true back to true by setting it to true. And that's it. That is the complete definition of the operations that are available to you on a Boolean state. There is no more. You might even say that that is what it is to be a Boolean value, these transitions. You can just say, aha, that state right there, those transitions, boom, that's a Boolean value. It's done. And there's no more to it. That's it. No more. And so that's, I think, pretty profound, because 19 billion years ago, or whatever, Boolean values were kind of sitting in the interstellar dust, kind of waiting to be discovered for life to evolve and mathematicians to come around and define them. And there they were, kind of hanging out. And when the sun dies and swallows up the earth, and we're all dead, and maybe maybe our descendants have moved on to other galaxies, and they're fighting with lightsabers and stuff. Booleans are still going to be around. They're there. It's this fundamental thing about the universe. So Boolean's a Boolean. It always has, always will be, and those transitions, those are how you move from one state to the other. They do not change. Okay? So, if we know that a number is a number, and we know that a Boolean is a Boolean, then why on earth are we rewriting these operations from scratch every time? Because that's basically what we're doing here with this boilerplate, right? We're re-implementing here the increment operation on a number again, and again, and again, and again. And so, at this point you might think that I'm kind of belaboring the point, and maybe I am. You might be thinking, okay, we get it. Numbers can be incremented, Booleans can be toggled. And if that was kind of the end of the story, it wouldn't be, of course, that big of a deal. But of course it isn't the end of the story. It's actually the beginning. Because it's not that working with an individual Boolean is hard, or an individual value is hard. It's when you start mixing them in and building more and more complex data structures out of those simple values. That's when things start to get challenging, right? Because here's, you're thinking, oh, this Boolean, it's so adorable, it's really small, it's harmless, it's cute. I want to hold it in my lap and pet it. And that's not, that's not really intimidating. But if I've got this Boolean value as a part of a to-do item, which has an id completed status, then, okay, I've layered a little bit more complexity. But then that to-do becomes an array of to-dos that are sitting inside of a to-do list, which might have, its own operations on it. Then, it starts to become a little bit more complex. And so here, I would say we have a really, I say complex, but this is still a toy arrangement, but we've got 3 levels of nesting. And so you can imagine a controller action right here that is just going to toggle a simple Boolean value. You've got to unpack all of those 3 levels of context. You have to actually change the Boolean value, right? We're going to switch it around and then set it back into the context that it came from. Okay, and so that's actually, if you look at this code, most of it is dealing with context and very little of it is dealing with the actual working with the value, right? Most of you've got here, we're getting the to-dos, we're iterating over, we're finding the one that we want, we're pulling out the thing, we're changing it, and then we're putting it back in. And so that's actually a lot. It's that's a staggeringly large paper cut that we don't really think about And this is really one of the more simple cases. I mean, if you weren't actually knowing that this was a Boolean toggle operation, that might just get lost inside there. So that's how, that is how a simple Boolean can, become complex. And that complexity is compounded at every level. And so, it's no surprise then that our state management just gets out of hand. It really becomes really difficult to work with. But the thing is it shouldn't be that complicated, right? Because we know what these things are, and we know what they can do. And so what if it was a world that we lived in where you could increment a number? What if you could just toggle a Boolean if you had a Boolean value and you didn't have to say how, right? What if you could just push something onto an array and you didn't have to say how? And that's kind of that is the overriding concern of microstates, is so that you can focus on expressing how your state fits together without the mechanics of how you actually manage the values in memory. Okay? We want it to be fun, right? We want it to feel like you're winning and like you're really being able to declare how your state behaves rather than moving beans around inside objects. So that's I think it's a pretty bold claim. So there must be, kind of something different that's going to set it apart from all these other solutions. And that something is actually something that's very familiar. It's this concept of type, right? Of type data. The knowledge, kind of this is what I've been dancing around here, is the knowledge that there are these intrinsic set of operations that are associated with your data. Knowledge like the fact that numbers can increment, right? That's what they do. Numbers increment. And everywhere you go, that's what they're doing all the time. And that's just, that's how it is. But the problem is that the systems that we use, the frameworks we use in our state management solutions are fundamentally untyped. We build them, like JavaScript is typed, right? JavaScript is strongly typed. Every value has a type associated with runtime, but the macroscopic systems that we build with JavaScript, in fact, do not have types. And that's actually, that causes us problems because it means that we don't have operations associated with the data. We're doing those operations every single time. And the problem is whenever you have this weak typing, you've got to do a lot of coding around to move those beans. And Ember, I would say, is actually pretty good. Like a system like Redux, or if I guess you can use Redux with Ember. There are a lot of benefits to it, but you have to write a lot of boilerplate. But if you have, on the other hand, you have strong types, then you can leverage that type information inside your UI, and you can just save a lot of time because you're just focusing on, how those types compose. So a quick divergence here. You might be thinking, okay, type, Charles is talking a lot about type. What about systems like TypeScript or ReasonML or Flow? Those are, what about technologies like that? And those are actually amazing technologies. I think TypeScript is actually really cool. I think just static typing in general is really cool, but static typing happens at compile time. It has no runtime footprint. It doesn't actually provide a function that you can call, right? Your JavaScript code provides the functions that you can call. TypeScript and type systems just make sure that those functions line up, that the call lines up with the expectation of the return and the argument types. And so that helps you during development time, right? It gives you code insight and gives you like that thing, but it doesn't actually give you anything at runtime that you can use, that you could say bind an action to. So What Microstates, on the other hand, actually provides you operations at runtime. You can think of it, it just provides you functions that you can work with to express the logic of your system. And it does it in an immutable way. And so you can compose these immutable types for great good. So it comes with a couple of built-in types, and every single type in your every single microstate type is composed of other types. So you have primitive types, and then those things are built up into more complex types. So here is our good friend, a number. And so this is what kind of the core Microstates API looks like. It's actually a very small, very thin API. There's basically one method called create, kind of at its core, which mirrors object.create. And that will actually return a new number microstate, and that number has a method on it called increment. I mean, I know this is shocking. So, hold on to your butts. But one thing to notice here is that this actually returns a new instance of a number microstate. It's not immutable, or it's not mutable, it's actually immutable. So I'm creating a number, I'm incrementing it, it actually doesn't change that number variable. It returns a new, bigger number that represents, that looks just like the old number, except it's one bigger. But the key takeaway here is to recognize that we are telling it what to do. We're not telling it how. So the same thing goes for Boolean. I can automatically, or I can create a Boolean object, and I'm automatically going to have a toggle transition. Array, I mentioned that too. If you create an array, you can push things onto the array, you can pop them off, you can map it, you can filter it, things like that. And those are the basic. Those are the basic operations. Did you have a question?
I did. Is your push method also immutable?
It is immutable. So it returns a new array that is just like the old array, except it has that. It has one more thing on it.
Mm-hmm. Number, Boolean, and array, are those the JavaScript classes?
This right here is not a JavaScript class. This is, what's that?
Where do we get array from?
Oh, well, that is a JavaScript class. But what is returned, this variable right here is a microstate array. Yeah. So we don't, but it's not, it's the built-in JavaScript objects have already methods associated with them. So it's a little bit of a cheat. So the primitive values kind of are treated specially. But then once you actually have those primitive values, then you can begin to kind of combine them and compose them into more interesting ways. But regardless, the operations, the objects that you compose will also have the operations of the objects from which they are composed. And that can actually be complicated to manage that state well if you're doing it by hand. And that means that you've got, you basically have a linear complexity curve. As you build your tree of objects bigger and bigger and bigger, you don't have to spend any time making sure that they coordinate or making sure that operations, because the whole tree is going to be acting as one thing in concert. And that's nice because it means that we can kind of let computers do the things that they're good at, which is doing kind of hard monkey work for us. So we've seen the built-in types. I gave a really brief overview. So how do we actually put these types together inside microstates to build more complex types? Well, it's actually really simple. You just use a simple JavaScript class. And so here we've got a class person. The person has an age property, which is a microstate, which is a microstate number. We're going to make the default value 0. This has a name attribute, which is a microstate string, which has empty string as the default value. And that's actually going to build a microstate tree of a person if you call create with the person, which I think we do in the next slide. Here we go. If we actually do this in the next slide, we've got this, we create a person, and then you can see I can get a new older person just by incrementing the age property of that person. And that's going to return a new version of the entire person. The only difference is that person's age property will be incremented by 1. And so that's actually very hard to do in an immutable fashion. But Microstates can do it for you, and that's actually very intuitive. So if you've got, here you can see what we've, this was the Ember controller. Here we're kind of descending through the context to do our operation, and afterwards you can basically flatten out. There's still composition here going, but it's just the composition happens just by virtue of navigating to the place at which you're performing the operation. So that's how you compose microstates, and really there's not much more to it than that. At least the composition, but obviously in your own custom types, right? The built-in types have their transitions. Our custom types, they need to have their transitions. So here, and those transitions are essentially the operations which are as intrinsic to your type as toggling is for a Boolean.
I've got a question.
Yeah. Mm-hmm.
So on after, is that returning a new? Like if it's immutable, is it making a new to-do that's completed?
Yes. So there is a little bit of magic that happens in the UI bindings for microstates, where you basically create a single mutable reference to an immutable object. So basically, this right here will return a new object, but it will also take that object and update a reference inside of a little store. But the store is basically so small you don't see it.
Okay.
And it's optional. Like you don't have to use that mechanism.
So is that is the change cascading? So in other words, the completed to-do got toggled, so it's a new to-do.
Yes.
And it's changing the array, so now the array is also new?
Yes.
Okay.
So it cascades up the entire tree. I think I mentioned, actually I don't mention it because it's not of interest to most people, but it will actually share. So in the tree, it will cascade up, and only the path from the site of the change upwards changes, and everything else remains completely the same. Like triple equals equality. Which is really powerful if you're Ember's great. It takes care of like that stability for you. You don't have to worry as much, but like in React, that is a huge deal.
And in the before example, you're picking out a to-do by the ID, and but down here, is this just element 1, or is that something?
Yeah, that's element 1. I should have that should have been ID.
Okay.
I should have looked it up by ID, or yeah, that was. Okay. You caught me. I was like actually looking at my slides. I was like, I wonder if anyone's going to catch that. That should have been the ID variable. Yeah, I should have actually, and I didn't. I didn't wrap this in a controller action. So basically, this would only replace that code, right? You would still need. Well, actually, you'll see in the demo, you don't. A lot of times when you're using microstates, you don't even need to write action handlers. But you would be able to do that. And you could either do it here, or you can more often than not, you can just do it in your template. So any other questions before we continue?
So at the end here, you'd have to reset to-dos to that, right? You have to reset the entire array.
Reset to-dos to what?
So I think what he's saying is that currently that to-do MVC dot to-dos, if to-dos ends up being a new array with like a new item in it.
Yes. So you would want to be replacing this to-do MVC object every single time. So microstates actually, because it's such a common pattern to take a tree, call a transition, then update a mutable reference. It actually and then that's the thing. it does come with a very lightweight mechanism to do that, but there is absolutely no reason that you couldn't, in your component, have an action that called this and then set that to the new value. And the point is when I call this toggle transition on this thing that's nested 4 levels down, I always get a new version of this entire object right there is what it returns. So that's actually great, but there's some principle that's like you're violating there called something coupling, I don't remember. So does anyone know do we have any pedants in the audience tonight?
The only multiple levels thing that I know of is law of Demeter, but
Law of Demeter, that's right. Or law of Demeter. What? Yeah. That's it. Yeah. So this is actually a pretty awful law of Demeter violation, right? You're coupling this to this to this to this to this. So to get around that, you can actually define custom operations, right? That's a perfect segue. So here I have a modal, and the modal is comprised of these 2 properties, each which have their own operations, but I have this operation right here, which is to show a modal. And you can see what that is doing is batching up transitions on the constituent objects and running them atomically and then returning a new modal with both of those things, right? So it's a way of essentially defining an operation which is a transaction over sub-operation. That's a fancy way to say it. But then if I create that modal, then I can now call my custom transition, which is my custom operation, pass it the arguments, and I get a new modal which has the consequences of that. And so that's one of the things that makes this composable and makes it reusable is these things are completely isolated in scope. You can only see inside of a transition, you can only see the properties which are part of that microstate. You can't see anything else. And this allows us we can put modals and put them into menus and routes and what have you.
So it looks like after .set, you have .title. So the return value of .set is the same value as this, except it's .isopen.
Right. So this right here, this isopen.set returns a new modal, and then .title.set returns a new modal.
2 open modals at that point? No?
Nope. Because this is why I put them on their own line, is because this right here is the modal, and at each point, yes, you are generating 2 modal objects, but no code sees those 2 modal objects. There's an intermediate state here, but that you're immediately chaining on these new operations, but nobody sees that except for this method. So yes, you are creating an intermediate object. But no one will ever see it because it's only used as an object to derive the object that is returned.
okay.
Does that make sense?
Yes, I mean, in that, the return value, you're only going to get 1 return value.
You're only going to get 1 return value.
And so it's just as long as set, you know what set's doing, right?
Right. So it's worth pointing out, this seems like an OO interface. These are pure functions that have no side effects. So it's not like you're going to go fire off an AJAX request inside this set, or if you call some other things. The microstates themselves have no side effects whatsoever. So you're just returning new state off of old state. And so at each point, you're deriving new state from old state. So I think now would be a good time to actually show some microstates in action. So we're going to make a little menu. We're going to use a microstate to drive it. So I have up here, if we look inside, I've got this Ember component. Can everyone see that? Is that big enough right there? So I have this menu component, and you can see here's the template that we were just looking at, and I've got this menu component right there. And so I told you about that little store mechanism. The store mechanism is actually optional. But it's really handy. You can just pass it any microstate, and it returns. It will basically give you a a proxy for that microstate. So all of the transitions do the kind of dance of invoke the transition, get the next value, set it to the, or basically emit a callback with that value.
So always returns the latest.
Yes, so what we'll store actually, you pass it a callback, and then it passes you the latest state every single time. So we're just taking the latest state, setting it on the model property, and then if we look at my menu HBS, right here, that's what we're doing here. So you can see it's taking the menu and yielding it in the template. And then, oops, and then I have just a little did receive adders hook so that if you do change the title attribute, it just sets it onto it actually just invokes the transition on the microstate. So you can see that's how this initial title got set. Okay, so then that injects it into the template. And that's a microstate object. And then the microstate objects themselves have a state property, which is the actual JavaScript thing. That's the actual JavaScript object that you use, the POJO that the microstate is wrapping. So if it's a number microstate, it's going to be a JavaScript number. If it's an array microstate, it's going to be a JavaScript array. So you can kind of think of microstate as like a little box that you're putting a POJO in and then transitioning that POJO through, and then when you need to take it out of the box to actually put it in your template, that's how you do it, is with this state property. So you can see we've got here the menu title state is cool menu, and I think that's the only state that we're really using right here. Okay, so here is here is the actual. So we look at this menu property right here. Oh, where's that coming from? That's coming from this model class, right? And this is my microstate that we're using. So the very first thing that we want to do is make it so that when I click on this like show button, the menu shows and hides. And so we're going to take, let's see, so here's our show button. First of all, let's make this an if statement. And I think you can do this, right? If menu.is showing or is open dot state, then we want to say that it's showing instead of just having it always be showing. Okay, now it's actually not showing, but now it's not showing, and when we click on it, nothing happens here. So the first thing we can do is we can take this show button and we can say on click. We're going to say menu.isOpen.set or .toggle. Let's toggle it, right? This is going to be an action. Okay. So now, if we toggle, if I can click on that button, and the menu is going to open and close for us. Now, you notice I didn't have to say what's going to happen when I show that thing. I just said I want to toggle this value, okay, and it generated the value. It took care of generating the value for me. I told it what. I didn't have to tell it how. Okay, and then we want to do, this close button right here. We want to, right now that's not wired up, and so here I'm gonna. We want to, take that guy and put an on-click handler. And that's going to be action menu dot is open. Now the difference here is that we actually want to set it to false, right? We want to explicitly say, we're not toggling like we were with that other button. We want to say, nope, we're closing the menu. Okay? So now we can do that, and then when I click that button, it closes. And again, I'm just declaring how how and when to use the actions that are just implicit to this data, right? So we can do, so now that's kind of maybe a little bit awkward because we're doing kind of our law of Demeter thing. So I can, if we go back to the menu, go back to the model, I can say, well, let's just, let's have an open transition, which is just gonna say this dot is open dot set true. And let's have a toggle operation, which is, return this dot is open dot toggle. And then finally we can have a close operation, which is return this dot is open dot set false. And we can use those operations instead of kind of we can just say menu dot close. Okay, and we should. What's that?
Should be menu.toggle.
Menu.toggle, you're right. Yep, okay, so that works. So, and then we can do, if we want to have some, this is a nice hover effect menu, so we want to, maybe if we take the mouse off, we want to close it kind of automatically so that we don't have to do that. So we could, add to this, we could say like on mouse leave action menu dot close. So we can open this and we can hover over it, but if we actually just move the mouse over, it goes away. So doing things like those are just Boolean values. Here's something also to right now we're saying menu dot is open is where we're kind of manually pulling the state off of this value. We also have computed properties inside these things, so we could actually have a computed property called get is showing. So we could just return that value. And so now we can just use this directly. Right, so that's kind of how you have computed properties in Ember, right? You can have, Microstates also has computed properties. I'd argue that they're actually a little bit simpler than Ember computed properties because you don't have any, there's no dependent keys. There's no magic. They're just JavaScript computed properties. So then I think there was one other thing that I wanted to show, which was doing like maybe a text binding. So if we wanted to say edit the title from here, we could say put an input, and then we could say on key up equals action menu dot title dot set. Like that. And so now we've got this thing. Oh, we should probably initialize the value and say the value is menu.title state. Right, so we've got like our cool menu, and then we have the you've got your 2012 binding demo, except this is one-way binding, and that's really it. I mean, it's actually a pretty simple idea, and kind of the nice thing about it is it works in whatever framework that you care to use. I think I have a couple more slides just to kind of wrap it up. Hopefully that demonstrated some of the benefits, but some of the things that you might not be thinking about, just, there's the code ergonomics. One thing to note is that the microstates are all lazy. So when I do a transition on a microstate, nothing actually happens. It's only when I start reading the consequences of that transaction. So as a result, like we've got some benchmarks, and this is you can hook a microstate up to a fire hose, right? Because it's basically, if you are throwing a whole bunch of events at it, it will be doing some nominal work, but it's not going to be doing really any real work until you try and read from it. So
quantum particle.
yeah, exactly. No, that's exactly what it is. So yeah, this toggle is not actually it's going to return a new object, but the properties of that object are not going to be realized until you actually start reading that. We already covered it's immutable. You got to see a little bit of that in the log. Every time you do a state transition, it's going to generate a completely new object every single time. And that helps. We don't have time travel yet, but at least for debugging, you can see exactly what happened, right? You can see like, oh, this happened, then this happened, then this happened, then this happened, and then that's where my state got messed up. We mentioned like computed properties. Ember has computed properties. Computed properties are awesome. It's one of the things that really I was in love with Ember for a long time. Microstates also has it, except they're just a hell of a lot simpler. They're just JavaScript computed properties. There are no dependent keys because every single object is a new object. So you don't have to know when it changes. The fact that you have a new object means that it needs to be computed again. Also, because it's immutable, we can memoize those expensive things like Ember computed properties. These things can and are actually memoized. So when you get a computed property, we get it once and then we cache it. And the reason is because it's an immutable object. The objects that comprise that immutable object can never change. So by definition, this computed property is a pure function. And so if this can never change, and a computed property is really, it's a pure function of this, then there's no need to compute it more than once. The other thing is it's really, really tiny. So there's a very thin API on top of microstates, but internally it's using there's monads and functors and profunctors and all kinds of fun stuff in there. So as a result, we can get the code really, really small. And I think right now it's about 5.5K gzipped. I think we're going to be able to get it down below 4. That's our goal, is to get it down below 4K. So that's it. You can go check out the README website coming soon, and that's Microstates.